Okay, thank you very much. Do we need a small break for 5 minutes or we can start now? I need to...
No, maybe it depends on Michal.
Yeah,
If we can start, but if not, maybe we should make a short break. Is it
break, please?
Hello, everybody.
You
hear me? We can start now.
Yeah.
If you are ready, I have no problem with this. But someone just wrote that we need a break. It's up to you.
No, maybe we can continue.
Okay. So, hello everybody, welcome to the last session. My name is Michal Plaček, I'm from Charles University, and I will be on chair of this session. We have 3 papers to discuss, and the first one should be Nikita German. The paper is named Experience in Public Procurement. Okay, then start.
Yeah, just a second. Hi. Sorry, do you see my my screen?
Yes.
Yes, it's okay.
Just a second. So, good morning, everyone. My name is Nikita German, and I'd like to present our research conducted with Елена Podkolzina and Andrei Tkachenko and called Buyer's Experience, Evidence from Public Procurement in Russia. Sorry for that. So, the procurement outcomes hugely depend on the buyer's characteristics, as buyers set contract specification and awarding procedure, and also monitor contract execution. And indeed, following Best Heard and Zakoni paper of 2017, around 40% of within product price variation in Russian procurement can be explained by procurers' time and varying characteristics. Okay. Also, Bandiera, Pratt, and Valetti use Italian data to show that inefficiency explains 83% of total waste during procurement process. But it seems that buyers' characteristics tend to change over time. And in our research, we consider one of the main factors which may contribute to changes in buyers' efficiency. That is buyers' experience. So we suppose that more experienced procurers tend to achieve better procurement outcomes due to learning by doing effect. So once again, the main question of our research is how procurers' experience affects outcomes and how its influence on the outcomes differs with the type of experience. Actually, I would like to skip this literature, extensive literature part, but overall the literature shows that the learning by doing has positive effects on different economic outcomes. Also, maybe this slide I will also skip. It is just general facts about procurement system. So what data do we use to examine experience effects on procurement outcomes? We use Russian data on road construction and repairs works from 2011 till mid-2015. And overall, we have 156,000 contracts in our sample. So a few words about public procurement in Russia. During the considered period, it was regulated by federal laws number 94 and number 44. And procurements, all these procurements were conducted by both federal, regional, and local entities. Main types of awarding procedures in our samples are sealed bid auctions and electronic auctions. And for the purpose of subsequent analysis, we define 4 price categories of the contracts using the following thresholds: 5,000, 3 million, and 10 million rubles. These thresholds have some institutional background. For example, awarding cannot be conducted via sealed bid auctions if contract's reserve price is greater than 500,000 rubles. On this slide, you can see the distribution of log of reserve price, and dotted lines separate different price categories. And you can see that the contracts are quite evenly dispersed between different price categories. So, how do we formally name the experience variables? We name total experience of procurer, the total number of contracts closed up to the date of the forthcoming auction. By relevant experience, we also name the total number of previously closed contracts, yet in the same price category as the forthcoming auction. Irrelevant experience is the experience attributable to the contracts in another price categories. So the sum of relevant and irrelevant experience is the total experience. We also disaggregate irrelevant experience in irrelevant experience, that is the number of contracts that were executed in price categories which are higher than the current contracts one. And down irrelevant experience, it is irrelevant experience attributable to lower price categories. We also introduce the definition of repeated contracts, and we name contract repeated if its procurers and supplier have previous experience working with each other. Okay. Here you can see the distribution of contracts by price categories and repetitions. Notice large number of repeated contracts in the sample, which amounts around half of all contracts. This means that for around half of the contracts, procurer and supplier have previous experience working with each other. So, following our definitions of experience, we hypothesize on the following effects of procurer's experience on procurement outcomes. First, we expect that more experienced buyers achieve better procurement outcomes. That is, they tend to have high competition at the awarding stage, lower delays, higher probability of contract completion. We also suppose that buyers' relevant experience, that is the experience in the same price category of the contract, has greater positive effect on the outcomes than experience in another categories. Another hypothesis is that experience in conducting complex contracts has similar effects on the procurement outcomes as relevant experience. And finally, we expect that contracts are better executed in case when procurer and supplier know each other. So to check this hypothesis, we build panel data models with procurer's ID fixed effects. We consider several dependent variables capturing outcomes on different stages of procurement process: number of applicants, number of bidders, delays, terminations, and others. List of controls includes type of awarding procedure, log of contract duration, log of reserve price, and another characteristics. So let's proceed to the results. Here you can see the procurer's experience effect on the number of applicants. We can see that when procurer is more experienced, the number of applicants generally increases. And this increase is mostly attributable to the relevant experience. Yet relevant experience seems to be insignificant. And also you can notice that upper relevant experience effects on number of applicants is similar to the relevant experience effect. However, more experienced procurers tend to apply stricter selection process, and this results in the higher number of non-admissions. You can see all these positive coefficients. And these two effects, when the number of applicants increases and the number of non-admissions also increases, results in the fact that number of bidders and the competitiveness of the auction, competition on the auction generally remains unchanged. On this slide, we show regression results for two measures of electronic auction competitiveness. The first is the indicator showing whether there were more than one bidders on electronic auction, and another measure is the price reduction. Here we can see, as expected, that actually no significant effects due to already mentioned no effects on number of bidders. Yet we see some negative effects of irrelevant experience on the competitiveness. We see that with higher down irrelevant experience, procurers, electronic auctions tend to have less bidders, and similarly, it results in lower price reduction. We also investigate with what types of suppliers do more experienced procurers end with. From here, we can see that more experienced procurers tend to end up with the suppliers they have previously worked with. Yes. Here we show the experience effects on contracts execution outcomes. We start with delays. Here we disaggregate procurers' experience on the experience with current contract supplier and with all other suppliers. As expected, larger number of previous interactions with current supplier, so the repetitions, tend to decrease delays, while the experience with other suppliers tends to not matter much in reductions of delays, for delays, yeah. And also we can notice that irrelevant experience with other suppliers can have harmful effects on delays. You see these positive coefficients here, yeah. We also consider experience effects on termination. And we see that with higher experience, with higher experience with current supplier, the contract tends to have lower probability of termination. Yet, the experience with other suppliers tends to increase the probability of termination, and this effect is largely can be attributed to the irrelevant experience rather than relevant one. So, to conclude, at the awarding stage, more experienced procurers are able to attract more applicants. However, this does not result in the direct increase of awarding procedures' competitiveness, as more experienced procurers tend to have larger non-admissions rates. As the result of awarding procedure, experienced procurers tend to eventually end up with suppliers they were previously working with. And this has positive consequences on execution outcomes. When procurer and supplier have larger experience working with each other, they achieve lower delays and lower probability of termination. Yet procurers' experience with other suppliers tends to matter less on the quality of execution or even harm it. If we disaggregate total experience effects on the procurement outcomes, we can see that its positive part is mostly attributable to relevant experience. Yet irrelevant experience can even harm results of procurement. It can result in lower competition on electronic auctions, increase in execution delay, and rates of contracts termination. The worst outcomes are observed for complex contracts, with procurer having large experience in simple projects and no experience with current supplier. So that's it. Thank you. Your questions are welcome.
Okay, thank you for a nice presentation. We can move to the next paper. Please, Pavel Andrianov, Adaptive Reserve Price in French Timber auction.
Okay, thank you. I'm going to share the screen now. Can you see the slides?
Yes.
Very good. So I'm glad to present this paper. Let me first announce that I'm working a lot in procurement, but this particular paper is not about procurement, but rather it is about selling the government property, which is standing timber in France. But it is very similar in every other aspect. So there are also always considerations of collusion, and there are questions of how to pick the proper auction design. In particular, in this paper, we're interested in the phenomena of a secret reserve price, which is the reserve price that is not announced beforehand, how it is usually done. And I think in the Russian data, we can find something approximately like that in the 223 law, where the auctioneer has the right to refuse selling the item in the end, which is essentially the same as the secret reserve price. So let me move on. The reserve prices are considered very important in both theory of auctions and in applied work. First of all, the reserve prices, they allow to solve the commitment problem, because if you don't have a reserve price, there's always a risk of renegotiation, which is very costly and exhausting for both parties. Second, optimal reserve prices allow to maximize revenue for the seller. Also, if we have informational asymmetries, the seller can use the reserve price to signal either cost or quality, or maybe if he's corrupt, he can confuse the bidders into believing that the contract is bigger or smaller than it actually is. And finally, secret reserve prices are typically associated with either trying to break down a cartel, a collusion among the bidders, or to somehow take advantage of risk aversion, so to force the bidders to bid more aggressively. However, if we take the most canonical, simplest model with risk-neutral agents and an IPV setting, which means independent private values, so no correlation of values between the bidders, then an optimal reserve price is always public. So you can actually prove, it's a very simple result that shows that no secret reserve price, no sort of mixing and randomizing reserve prices can help increase the revenue of the seller, in both for the efficient seller and for the profit maximizing one. So really, secret reserve prices are a big mystery in the auction theory, and most people actually dismiss them as stupid. So in our paper, we focus on a case study of the secret reserve prices who have been persistently used for half a century, I think, by the French Office of National Forests. These auctions are first price sale bid for standing timber, which is just a chunk of forest that is about to be cut. It is typically either a public property, like the government owns it, or it is a municipal property owned by a small commune in France. So the most important part of this auction design is that there is no public reserve price. The only signal that the buyers get is that they go physically and walk through the forest and estimate their own value. There's also tons of characteristics in the catalog. So you know the area, obviously, you know the approximate volume, and the constitution of the forest. And finally, almost 50% of the lots in these auctions, they remain unsold, despite the high participation among the others. Among the firms, almost half remain what is called in-house. Okay. So this is a very well-known case study, and it was first brought by Lafond and some other French researchers. The data that we're using is slightly more modern. It was collected by Cost and Per Game 2004. So we just borrowed their data set. And there's a slightly more modern study that where the economists, they interview the bidders directly. Overall, the environment is very well studied. We know almost every detail about how these auctions work and what the bidders think. And the crowd wisdom appears to be that the secret reserve price exists because the seller himself does not know which reserve price to set. And in other words, after the auction is performed, the seller would like to keep the last word. So he would like to keep the opportunity to not sell the forest today and just keep it for the next year. The forest can keep growing, and then maybe next year the demand would be higher and you can attain a better sale. In other words, the seller is less informed than the bidders, or is completely uninformed about the true value of the forest. So the main thesis is that on the one hand, the optimal reserve price is always considered to be public, but if the seller doesn't know the true value, the reserve price can be used, the secret reserve price can be used as a tool to, sorry. So in two words, basically the seller can try to learn from the bids his true value and then decide whether to sell the forest or not. That is kind of the main idea behind this secret reserve price. So can we formalize this or not? That's the first, that would be the first empirical puzzle that we're trying to solve in this paper. And there's also a second empirical puzzle which we have only encountered while we started working on it. It is that in the data set, there is actually a written sort of recommended reserve price, which is, however, not enforced. So there is a number which is called the reserve price, but the auctioneer doesn't have to obey this number. In particular, what is observed in the data is that when the highest bid among the buyers is higher than the recommended reserve price, then the forest is always sold. However, if the highest bid is below the recommended reserve price, the forest is sold with about 50%. So let me try to explain this visually. Imagine on a plane and on the horizontal axis you have the reserve price, and on the vertical axis you have the maximal bid. Then I want to throw a scatter plot of the auctions and color them in red and green. Red would be the auctions that were sold in the end, and that were not sold. And green would be the ones that were sold. So if I visualize it like this, once again, on the horizontal axis, you have the reserve price, and on the vertical axis, you have the maximal bid. And I want to plot all the lots that were not sold. We would see them below the 45-degree line. This is absolutely normal. This is what you should expect in the typical auction, right? This means that the red cross means that the reserve price was higher than the maximal bid, therefore we're not selling this forest. Now, once you want to plot the second half of the data, you should expect it to be above the 45-degree line. So for the lots that were sold, we would expect that the maximal bid was higher than the reserve price. However, it turns out to be not the case. In fact, this scatter plot completely ignores this 45-degree line as if it doesn't exist. And this is the second empirical puzzle. Let me combine these two scatter plots here. Why do you always sell when the winning bid is above the recommended reserve price, but you never sell when it is below the recommended reserve price. So yes, basically what we're trying to argue is that this looks as if the auctioneer is revising his estimate of his reservation value in the direction of the bids. You can rationalize it with this very simple formula where you would have an exempt reserve price, which is the recommended reserve price, and the exposed reserve price, which is not observed, but we can imagine that it's somewhere. It is a counterfactual number, and they're connected with this simple formula, which is a linear or maybe log linear weighting of the winning bid and the reserve price. If you use this formula, then you will have this nice property that whenever the highest bid is above the recommended reserve price, it is also above the updated reserve price. So this does look a little bit like the auctioneer is revising he's looking at the bids and he's updating his private information and he's revising the reserve price after the auction was run. How much time do I have left?
Ten minutes.
How many?
10.
5? 10 more minutes.
10 minutes.
10 minutes.
Okay, so what we're trying to do in this paper is to provide a certain answer to this empirical puzzle, while at the same time taking advantage of this very particular pattern in the data that I have showed you, which is the red cloud and the green cloud, and the one being below the 45-degree line. So our main innovation is in the paper is the introduction of this updating rule, which is something, it's an imaginary thing. So there's no updating rule in the data. There's actually no updated reserve price in the data. There's only a binary decision. There's either 0 or 1. However, there is this, the preliminary reserve price. It is in the data. And we believe that they should be connected through some structural equation, maybe with an error, but loosely speaking, we think of it as either linear or log linear weighting. So we build a new model with an auction where the auctioneer has this recommended reserve price in the beginning. Then he observes the bids that arrive in the first price auction, and then he revises the reserve price, all secret. And then in the end, he announces whether the highest bid was above or below this revised reserve price. So what we do, we defend our informational assumptions using formal statistical tests. You can find it in the paper that was uploaded. We provide some fundamental identification results for the model. Because it is a non-parametric model, the identification is not obvious. And then we estimate the model and run a number of counterfactuals. Obviously, due to the time constraint, I won't be able to show you all of it. And I only want to talk about the identification of the model. Okay, a quick description of the data. It was collected in 2003. It was 10 groups of auctions, and the total of 2.2 thousand timber tracts were auctioned through the first price sealed auction. In the data, we observe everything that was in the catalog, which is the area, the volume, the composition of the forest, all the things that we typically add into the regression. And then most importantly, we observe the recommended reserve price, and we observe the final decision to sell or not. But we do not observe anything that would connect those two. So that we have to imagine or invent or do something about it. So a quick explanation of our model is that the auctioneer observes a noisy signal about his true reservation utility. So unlike the classical model where he would typically either have no reservation utility at all, or he would have just a 100% probability a certain reservation utility, Here he observes a noisy signal, so he rather has a distribution of reservation values. So he forms his final reserve price based on the information that he receives through the auction. And this information contains the bid order statistics of the firms and his prior signal S. And we believe that the connection between the final reserve price and this information is somewhat linear or maybe log linear. This is our main innovation, and we try to estimate this model. The primitives of the model are, there are 3 distributions. The first one is the idiosyncratic variation of the bidder. There's also a common component which affects both the valuation of the firm and the auctioneer, and there's the seller's noise. Basically, 3 distributions are supplied into the model. So we impose additional multiplicative structure. That is, the true bidder valuation is the product of the 2. This is quite common in structural auction estimation. We assume that Y, this common component, is basically the scale of the auction. You can have either big lots, small lots, maybe high quality, low quality. It just stretches the auction proportionally. Then the bidder observes this common component, but not the seller. The seller observes a noisy signal. And then the seller commits to an updating rule of a certain shape, observes all the bids, observes his signal, and finally makes a decision to sell the lot or not, depending on whether the highest bid has exceeded the updated reserve price. And then the final assumption here, which allows us to achieve our identification, is that the exposed reserve price is homogeneous of degree 1. This is a very strong assumption, but basically all of our results can be traced down to this particular thing. And it's very natural because it basically tells that if all of the bids and all of the private information is scaled proportionally, then the outcome of the auction should not be changed. It basically means that this revision rule is independent of the units of measure. It doesn't matter whether you're considering rubles or pounds or dollars or maybe thousands of rubles. So the revision rule would be the same. Okay, so I think I'm slowly running out of time. Let me just spend a couple of minutes explaining the estimation. Typically, if you were trying to do a reduced form research on auctions, you would require the winning bid and the cost of the firm. However, very often the costs are not observed. And so instead of doing that, you can take the winning bid and the losing bids and use the first order condition from the model to compute the cost from the losing bids. So it's just an alternative approach, but it's highly nonlinear, and the first order conditions, they are all nonlinear, and it requires non-parametric estimation and quite complicated simulations of counterfactuals. The standard model would be just simply the profit margin, your type minus your bid, times the probability of winning. Here we also have this strange exposed reserve price, which has to be checked. And so we need to separately estimate the residual curve and this strange conditional winning probability. But it's possible in the IAD setting. Unfortunately, the setting is not IAD, which means that these curves, the residual curves, are extremely flat. They're stretched over a range of from 0 to, I don't know, 10,000 pounds. And they're almost all the time horizontal. And if you just use the first order condition, you'll have also very flat strategies, which is very bad. And basically, we need to come up with something to compact these residual curves and get a sensible strategy. This is the problem, which is very similar to heteroscedasticity in reduced form research. In the auction theory, it's called unobserved heterogeneity, and there are certain tricks to take care of this. Basically, to acknowledge that there are big and small auctions and then put them together intelligently. So we do that. And then we will have 2 identification results. The first one is that you can, from the bids, you can identify both the common component and the private component of the bidder. And then if you also assume an additional structure on the exposed reserve price, which looks just like a simple normalization, you can also identify the signal. So remember we have supplied 3 distributions into the model, which was S, Y, and V. And then using the first order condition and this additional structure, we can recover them from the observed bids and from the ex-ante reserve price. But these are our 2 main identification results. And then using those, we can run all kind of smart counterfactuals. For example, we can run a second price auction, or we can maybe give the auctioneer the full information and see how much his revenue would increase. And these counterfactuals you can find in the paper, but I'm not going to talk about them here due to obvious time constraints. So that would be all. Oh, there's also the proof of the second. So if you're curious, you can see how that identification works. So that would be all. Thank you very much.
So thank you for your presentation. And last one is Paula. Please, you can start with your presentation.
Yes, Pavel, could you stop your
Right.
sharing, please? Okay. Okay, I cannot. Still sharing. So you have the bar below. Okay.
I can help you.
Okay. Let me see. This one. Could you see my screen?
Yes.
Okay, let me just open this. Okay, no, I'm completely wrong. I am here. So, okay, so let's go in this way. Okay, so first of all, thank you very much for having me here. And in my 15 minutes, I will present this paper joined with Riccardo Camboni, Luca Corazzini, and Stefano Galavotti. It is a paper on multidimensionality and complexity in scoring rule auctions, and it is an experimental paper, so it was really an extended work. We already have the working paper, and in my 15 minutes, I will try to give you the flavor of the analysis. Then I am obviously very happy to reply to any further question, and you have the working paper version also on the web. So what we try to do in this paper is just to focus on the selection procedure. So I have not to explain why this is relevant in such a workshop in which everyone is working on public procurement. What I want to stress is that in the real world, what we observe is that there are 2 main auction mechanisms, which are exactly on the opposite side of the same line. We have on the one side the first price auction, on which the supplier bids on prices, and so we have the buyer define all the technical characteristics, and the lowest price will win. So this is the simplest and the most used. Then we have on the other side of this line, and in between there are different mechanisms somehow which could have a different aspect with respect to these 2 extremes. We have scoring rule auctions. According to this mechanism, we have that the offer by each supplier includes both price and quality. We can have a different level of quality. And this element will be weighted by a scoring function, and the winner will be the one with the highest score. Now, we know that, and also from the keynote as well, we understood that this scoring rule auction have started to be largely adopted in many countries. The European directive as well, they push to implement this kind of auctions. Why? Because as by the paper by Asker and Cantillon, we have that the scoring rule auction dominate the first price auction, at least accordingly to this theoretical result. And the idea is very simple. Why this happens? Because if we are in an auction with heterogeneous bidders, we have that this SRA mechanism promotes competition, and we have that each supplier will submit its offer, which is the offer which will match its own productive skills, and this offer will have the characteristic to really be on the elements on which the supplier have a competitive advantage. So at the very end, the winner will provide a very high quality. This is the simple intuition behind this theoretical result. The point is that, and here is the aim of this paper, the point is that the scoring rule auction mechanism involves a more complex decision for the supplier than for in a first price auction. Why? Because you have to consider when you submit your offer, you have to consider to do a multidimensional choice. In particular, the larger the number of quality elements and the greater could be the complexity in providing this offer, which should somehow pose attention on price and on the different level of quality and the related weights which are defined by the public buyer. So our point is that it could be that the greater complexity which is behind a scoring rule auction can affect the bidding behavior, and as a result can reduce this theoretical superiority of the mechanism itself with respect to the first price auction. So what we want to see, what we want to investigate with this research is the trade-off between optimality of the mechanism and complexity of the mechanism itself. And I don't want to stress too much, but just to give you a few words about the literature. As you can see, there are a couple of very good papers on the theoretical properties of this scoring rule auction. Then there are a couple of very good papers on the empirical evaluation of this auction mechanism, and a bunch of paper experimental, but all the experimental papers are not on this issue on complexity versus optimality, but are on specific and different elements. For instance, Albano is on the relevance of the weight for each element of the scoring auction, and the others on other elements. So this is just to say that our question is a novel one. And now let me just move quickly to the experimental design. So I will present the baseline game, which is how we design the scoring rule auction. Behind all this function that of these functional forms that I'm going to present. Obviously, there are assumptions and there are extended motivation that I do not have time here to explain. But again, I will be more than happy to discuss with you later on. And the design for, let's start with the scoring rule auction. So what we do, we compare 5 treatments. So we have 5 treatments in our experiment. One is for the scoring auction, and the other 4 I will present in a while are 2 on a first price and first quality auction, and the other 2 are some extension of the scoring rule. So let's start with the scoring rule auction. Is exactly this one. So you have that in the experiment there will be 2 sellers. and there is an auction in which they have to, through which they have to sell an object to a buyer. Okay, this is the buyer utility function, as I mentioned, is with a specific form. And as you can see, there is the bidimensional bid, which should be on quality and on the price by the sellers. So the participant in the experiment will play the role of sellers, and they should decide about these parameters. They should decide according to what? According to this scoring rule function, which is given by this formula, where we assume that this seller, they have a quadratic cost of this type, and in the experiment there are 10 types of agents, so 10 types of sellers. Okay. Now keep in mind this scoring rule auction here, this formula, and then we move to the other 4 treatments in which we have first price auction. That is, we fixed the queue, and we just, and so this means that the sellers, they have to bid only, so since Q is equal to 16, they have just to bid on P, okay? So on only this part. Then we have another treatment with the first quality auction, where we fix the price equal to 32, and the sellers, they have to bid on just on quality, okay? These are the 2 treatments in which the sellers face only one dimension in the auction. Okay, so before you had the scoring with the 2D dimension for the bid, here you have other 2 treatments with only one dimension. And then we have somehow 2 further treatments which are in the middle of this scoring rule and first price first quality, which are the scoring rule auction 2 quality. Why? Because now the dimension of the quality is not a continuum, but it is dichotomous. So they can bid low quality equal to 9 or high quality equal to 40. And then there is another treatment in which the variable which is dichotomous is the price, with a low price equal to 12 and a high price equal to 65. So why all this design? What is the aim of the design? The aim of the design is to investigate the bidding behavior, even different setting of the auction. So starting from the simplest one, which is the first price auction, then moving to the first quality auction, where you have only one element on which to bid, then moving towards the scoring rule auction with all the 2 elements on which to bid, and some intermediate scoring, like the 2 quality and the 2 prices. Okay, so obviously of this all these treatments are set optimally in the sense that they maximize the buyer utility, and the experimental design works as follows. We have 24 subjects in each session. The experiment, each session run for 15 periods. And in each period, these subjects are randomly partitioned in 12 pairs. So you have pairs which they compete to sell this good to the buyer. And there is this rematching group procedure, which allowed us to have more observation. We have 3 sessions for each treatment, and so we end up with 12 independent observations at the rematching group level. We use Z3 as the program to run the experiment, and we run it in Bocconi. So the subject with which participate in the experiment were undergraduate students in this university. And we gave to this subject a sort of initial budget. So we gave them 20 tokens just to cover the possibility of losses. And on average, they play, let's say, they play this experiment for 70 minutes, and they have been paid about 15 euros. At the end of the experiment, we also gave to this subject a questionnaire with, in which we ask some socio-demographic information. We try to test for their risk aversion and the joy of winning. Okay, now, As I mentioned before, it is a research with, in which we started with theoretical prediction. We have theoretical prediction on buyer expected utility given the 5 treatment, on seller payoff, the level of quality in the treatment in which they can choose for quality. But what I want to give you the idea, I just will go for this part on welfare. So the prediction on welfare is as it is reported in the slide. So in equilibrium, in terms of total expected welfare, all the treatment are below the first level, and this is quite obvious somehow. And we have that the ranking among treatment is the following. We have that. As I mentioned since the beginning, the scoring rule auction will provide the highest welfare, which is highest with respect to the scoring rule auction with the choice on the 2 level of prices. Then in turn, higher than the scoring rule auction with the choice on the 2 quality, then first quality and first price. So as you see, from this theoretical prediction, we have the scoring rule auction on the one side and the first price auction on the other side. And to measure welfare, we just went through 2 main measures. So the first one is maximum surplus, which is the maximum possible surplus given the bidder type. Remember that we have 10 bidder types, which are randomly extracted, and each subject knows about its own type, but obviously the competitor in the auction does not know which is the type of the opponent. And then we have the relative efficiency, which is the overall surplus from that auction over the maximum surplus definable. So here, maybe this is the main point I want to do in this short presentation. Here you can see some experimental results, but first let's go to the column in the center, which is the predicted relative efficiency. Okay, so you can see that the highest predicted relative efficiency is the one by SRA. Okay, so by scoring rule auction. Then the second is by the second is by SRA 2P. Then we have SRA 2Q and first quality auction and the first price as at the very end. On the first column, differently, you have the observed results from our experiment, and you can immediately see that this ranking is not anymore the one from, as we can see from the predicted, but we have that the first quality auction is the one with the highest relative efficiency, followed by the SRA and the other couple of the SRA with the choice on the 2 variables, and finally as well the first price auction. So this is something that somehow we want to explain. So we want to explain why we have some prediction that moves having the move to have the scoring rule auction as the most the highest with the relative efficiency, while in our result we have a completely different ranking. The same could be seen for the ranking when we observe the efficiency relative to the Nash equilibrium. But here as well, maybe you can even observe in an easier way. Here you have the plotted equilibrium score as a function of theta. You see on the horizontal axis, you have the different types, so from 0 to 10 types. And so you can see each color is one treatment, and we have all the 5 treatments plotted, and you can see that the equilibrium score is strictly increasing in the theta. So the highest theta, which are the most efficient, will lead to higher equilibrium score. And the highest equilibrium score are for the scoring rule auction. This is obviously the prediction, and the lowest is for the first prize auction, and all the other treatments are in between. Now, if we move to our results, how much time do I have?
5 minutes, please.
Okay. So if we move to the results, here our results, you can see that the score, the highest score is recorded by the first quality auction, and then it is followed by the two scoring rule with the dichotomous choice. Then we have the scoring rule auction, and finally the first prize auction. When we use this scored distance measure, which is this one, which is the percentage distance between the observed and the theoretical predicted bits, we can see something which is very interesting. We can see that the first prize auction recorded something like 4.54% of overbidding score, higher than the predicted one. What does it mean, overbidding? Overbidding means that in that auction, bids are more aggressive than the theoretical one. So this means that these more aggressive bids determine lower profit for suppliers, but at the same time could give a higher benefit for the buyer because he's paying a lower price. While we observe overbidding for the first quality auction, we have that all the three scoring they record underbidding, so the score lower than the predicted one. And okay, here as well you have the score, but I have no time to enter in details while I want to move to this to the slide on discussion. So what we got from this simple first empirical result from our experiment, we got that there is a mixed evidence for bidding behavior, and in particular we have that there is a change in the behavior when we move from the unidimensional to the multidimensional choice treatment. So from the first prize, first quality auction to the scoring, to the three scoring. And this change in behavior cannot be explained by the risk attitude of our subject. So our point is to show in this second part of the research of the paper is to show that this kind of change in behavior in the different auction mechanism could be related to the degree of complexity of the auction. Why? Because having the design that I very quickly presented, we can control for the number of dimensions. So we have treatment with where subject has to choose only one dimension, or treatment in which auction in which subject has to choose over 2 dimensions. And moreover, we have also the type of choice set, which is could be continuous versus binary, which can also create some complexity in the choice. To show you that there is some difference in the choice, I briefly comment this table on response time, in which you can see we have differences in response time, and you can see that those auctions with only one choice, so first price and first quality, they record lower response time with respect to the other auction where you have to choose over 2 elements, or over 2 but in a continuous way. So this is somehow an evidence of a more complex task in the scoring auction with respect to the first price and first quality. Now, how we show that this complexity could matter in the outcome of this of the scoring mechanism, of the auction mechanism. We simply implement a quantile response equilibrium model, and this quantile equilibrium model is to test the hypothesis that the individuals, when they faced with more complex tasks, so they have to do a more complex choice, as in the scoring auction, they are simply more likely to do errors. And indeed, this quantile response equilibrium model is built on the replacement of the hypothesis, the usual hypothesis according to which every subject always chooses the strategy that maximizes his or her payoff, is simply replaced by a probabilistic choice function, which is tuned by an error parameter. And the probability of playing a suboptimal strategy related to this error is positive, and it depends on the relative payoff which is associated with this kind of setting. So we went through all this analysis following this quantile response equilibrium model, but I do not have time here to present all the analysis. We also check on our hypothesis on real data. We got the data by this very good paper by Lewis and Bajari, Quarterly Journal 2011. They gave us their database on California highway procurement contracts, and we also perform our analysis about this complex auction with respect to simplest one. And just to move to the conclusion, as time, I'm over time, I think. So what we show in this paper, we show that there is this trade-off between the different mechanisms mainly adopted in procurement, in particular between scoring rule auction and first price auction. And there is then a relevant result, which is that the first quality auction we have seen that perform better than the scoring rule auction. And this is exactly given by the fact that that subject, they still have to decide about quality, but they have a unidimensional choice to do, while in the scoring rule auction, they have the choice both on price and on quality. About bidding behavior, we found overbidding in first quality auction and underbidding all the scoring auctions. And we want to explain this different bidding behavior by the quantile response equilibrium on bounded rational bidders. And the main point that this kind of result, sorry to have presented very quickly, is tried to make is that if on the paper with a very good and nice theoretical models, we have that the SRA could provide advantages in efficiency, welfare, and this outcome with respect to first price auction or other simpler mechanism, we should be very careful in their application, because this kind of advantage may vanish in practice. And the optimal mechanism, so the mechanism which have to be implemented, should always take into consideration the bidder's bounded rationality. And I stop here. Thank you very much.
Thank you for a nice presentation. We can start with discussion. Uri, are you ready? Uri Němec? Okay, I will start instead of him.
Yeah, please.
Okay. I have only general remarks. I want to talk. I want not to talk about the technical issue of the papers, but I really do appreciate the topics because I think that information and experience is more and more important issue today. In previous session, we spoke a lot about corruption and about principal agent theory, but I think it's a more complicated story, and maybe the influence of information and experience maybe be more important than narrow story about corruption, because there is more approaches in public administration theory, like stewardship theory, and we made some research about public procurers, how they work with information, and we mathematically proved that they overestimate and underestimate some information. For example, the probability of ceasing the public procurement from regulator or cancellation of the public procurement. And I think that this issue or story is according to the actual general economic theory about the rationality or something which do Filip Matějka or Jakub Steiner from Czech Republic. So thank you for your papers, and so we can have discussion from or some question from other colleagues, or we have break.
Michal?
Oh, you right?
Yeah.
You can start.
I was also expected to speak, but in general, I cannot say much on these kind of rather technical papers. And to be open, I would expect, it's a general remark for papers in this session and some others, I also would expect much better discussion. If I read papers which we received, they should not finish with results, but with very good discussion of what was found, if results are relevant. Because in many cases, any small error in processing data by statistical means can deliver results which cannot be confirmed in reality. So it's not so much comment, it's suggestion. And what we also try to do with Michal, after each quantitative analysis, we try also not only to have the standard tests, but also to check to what extent our results are realistic in real life, or if we did not calculate something what maybe is a little bit too far from reality. So it's something like general remark to papers from this session. Thanks.
Thank you. So any question or comments to particular papers or any discussion? Okay, Andrei.
If I can just a very quick reply to your point. This research, this experimental research on result from a scoring rule auction is exactly from evidence of the real application of scoring auction, because you can see that in scoring rule auction, applying a scoring rule auction, you can have a lot of favoritism, because you can really put the weight to favor someone which is close to you as a public buyer. At the very end, it is not for sure that they are so good as the theory stressed. So the idea went exactly from the anecdotal evidence, because at least in Italy, but in other European countries, we were forced to use this auction with the quality, elements inside. But first, the buyers are not so good in designing this scoring rule auction. Second, they could be really very keen to include favoritism or whatever. And third, the result we got are not really on giving evidence that the scoring rule auction are working very well. Thank you for the comment.
Welcome. Please, Andrei, you can start.
So I have a question to Pavel. So what I could not understand, if the recommended reserve price is common knowledge before the auction, or do they open this recommended reserve price only after the auction? So, because this will change the behavior. And this is the first question. The second question, did you try to check your model for additive unobserved heterogeneity? So because your basic result is for multiplicative unobserved heterogeneity. And the third, maybe more important one. So this picture which you showed when below the 45-degree line, we always, so all the canceled auctions, let's call them like this, yeah, non-awarded auctions are below the 45-degree lines, and all the awarded auctions are everywhere on the below and above the 45-degree line. So I might think about another story. So let's assume that the buyer, the seller of the timber, he knows very well the areas, and let's assume that he knows that one area is luxury and another area is like, let's call it standard. And and he might know that if the bids for the reserve, if the bid for the luxury area is very small, he's not ready to sell this because he knows that he might sell it later. But if the bid for the standard area is below the reserve price, he's more or less indifferent because he doesn't care a lot about this area. So in this case, I would expect to see the same graph, but the story is completely different. In this case, the buyer or the seller of the timber knows the quality of the timber. So that is, he knows the reserve price well, but he might maybe, let's say, manipulate with the reserve price, something like this. Thank you.
Okay, thank you for your comment. So first, back to the recommended reserve price. I didn't have time to expand on it enough, but it's kept secret from the bidders, and it only appears in the protocols, and we see it as researchers. So there was some recommendation, but as I told you, it's in 50% of chances roughly it's not followed. So if the bid is below the recommended reserve price, very often the seller still sells the forest. That's for your first comment. For the second one, we of course tried all sorts of reduced form analysis to try to pin down which feature of the forest is responsible for being below or above, for being sold or not sold, and actually none of them are. So all the forests that were below, that were not in their place, they look exactly on average the same as the ones that are where they should be. The only thing that really matters is the distance to the recommended reserve price. So if you have landed just below the recommended reserve price, almost surely you will be forgiven and the forest would be sold. If you landed really far away from the recommended reserve price, then almost surely it will not be sold, which makes sense. And it also consistent with our updating story. So that's my answer. Thank you very much.
Thank you.
I have a question. Can I just have a couple of comments on the paper by Andrei, Elena, and Nikita? Okay, I have first a point about the result on experience and number of bidders. There is a nice paper by Marinello and Coviello, if I remember well the two names. So in any case, Decio Coviello and the other one I don't remember, in which they show that the number of bidders in the auction could be different accordingly to the different kind of advertisement that the public buyer is implementing. So I wonder if you could check where this public buyer, they publish the announcement about the auction. So to see if the experience is related to this kind of element. So it is not experience by itself, but it is experience via, so through the way in which they advertise the contract. And this is one point. The second point is that if I understood well the experience, so the buyer experience you have is related to, is defined along with the reserve price. So how much time they went to award the contract of the same reserve price size. And okay, it is obviously a way to define experience, but it is not. I would stress that it is not the experience of the buyer, so of one person, because it could be that you have a different person in the same office in the year in which you have your data. So it is maybe a sort of team experience. So experience which has grown up with that kind of institution or within that kind of institution. And moreover, the comment is, I know that you worked on a contract road, it was road maintenance or road construction. If you, the question is, maybe you could try to see a specific kind of contract in which there is less quality at work. So it is a very standard work. And and try to do a sort of robustness check, because in this set of auction in which quality does not matter at all or very little, you can have really the definition of your experience, which is really could be really strong, because the buyer has not an experience in quality, so it should not face the quality, but just according to the reserve price. Thank you.
Welcome.
Thanks for your comments. Regarding the first comment about advertisement, so we actually, yeah, it's interesting to see whether more experienced buyers are able to provide a better advertisement. And actually, it will likely be the case, as we see that really number of applicants increases with the buyer's experience. Yeah, but yeah, we can look in more detail on this. And regarding your second comment about the fact that probably experience of the team is more important than the experience of single entity. Yeah, it should be true, yeah. And we will try to just, I don't know whether there is data on this. I guess it is. And probably, yeah, it will be better to associate this experience with particular persons. But I guess associating it with some entity is also, I mean, it also has some point, there is also some point in this. And finally, about your, just about your final point about just limiting the sample to the set of some homogeneous contracts. We tried doing this. We separated the sample in repair works and construction. The repair works are more homogeneous, and we actually didn't see much difference in the results. Yeah, but that's a good point. Thank you.
Thank you. Any other question? Nobody?
So,
I have a small point regarding to Paula's paper. I am interested in risk aversion of public procurers, or how it can influence the process of setting criteria of public contract, single or multi-dimension criteria, according to your opinion on the research.
Yes, it is really a good point, and unfortunately, with this experiment, we went to study the bidding behavior, so the other side, the side of the supplier reaction with respect to the simplest auction, like first price, first quality, and the most complex one with the scoring rule auction. But you're right, because there is another research question that we had in the agenda and we still did not approach, which is how much the buyer competence or risk attitude or characteristic affect the way in which he or she design the auction. And this is somehow also related to all the issues about favoritism, or as we discussed this morning, the issues about how discretion the buyer has. Because it could be that, for instance, in Italy, we have that for some sector, the scoring rule auction could be designed with the two weights, 30 for price and 70 for quality. In other sectors, you have 40 and 60. So, you know, you can have also completely different risk attitude, and you want to be very sure that you pay the less. You're not interested in the quality or not too much, or the opposite. But if you have this kind of rules, obviously your discretion is very low. But I do not have really a proper answer, because it is one point we wanted to investigate, but we still not develop the research approach.
Okay, thank you. And second, only opinion question. Could it be caused by administrative tradition? Because I read many papers which describe behaviors of bureaucrats in Central and Eastern Europe, and they prove that the risk aversion is connected with post-communism or communism issue. And this behavior and a lack of bureaucratic entrepreneurship is connected with bureaucratic tradition of Central and Eastern European countries. And I think that in Italy, we have Napoleonistic public administration.
Yes,
and
according to the Bandiera Valletti, yes, that is true. But on the other hand, at least a part of the research approach could be also related to the incentives. So how you design incentives for these buyers. So if they have a full responsibility in an auction which is completely wrong, okay, obviously they don't want to risk, and plus their risk attitude. So all this together could provide a certain behavior. So you can even change or somehow interact with the buyer risk attitude designing incentives. For what I know, for instance, in France, buyers, public buyers, and the bureaucracy, at least on the top level, they are fully responsible for the outcomes, which means that they are paid very well, but at on the other hand, they have to pay a lot if something went wrong. So maybe your second question about the political, so the design of the bureaucracy in each country is also related to the system of payment and to the incentive these bureaucrats they face. So obviously in a country where, as in Italy, they are not paid very much, they try to risk the less. So they try to be the more close to the rules. They do not try to be entrepreneur at all, because they have no benefit from from risking more. So I would try to obviously to understand before to answer the question. I would try to understand very well what is the setting of the in which these public buyers are playing.
Thank you.
You're welcome.
Any other comments or question? Okay, thank you for participation in this session. I think we can close the discussion. So, and
no, yeah, maybe I will say some final words. No, first of all, thanks a lot for all participants. In my opinion, we had quite interesting discussion. Of course, it was different papers, but in any case, it is, in my opinion, quite a nice picture of research in this area. Yeah. So, and again, I'm really glad that finally we could organize it, even in this new format. It is also some kind of new experience for all of us, I suppose. And I hope for development of some kind of cooperation for the future. And I would stress that the opportunities to publish papers at two journals edited by Michal and by Juraj. So, and I suppose, no, of course, it depends on the will of authors and also on the interest of journals. But in any case, it is one of opportunities, and I suppose maybe Juraj and Michal can take initiative and maybe to ask relevant people about next steps and so on and so on. And again, I hope to see all of you in the future, maybe not only online, but also offline. So thank you very much.
thank you.
Yeah, okay.
Thanks also.
Yeah,
Thank you very much. Bye-bye.
yeah. Okay.
Thanks.
Thank you very much, and bye-bye to everybody.
Thank you, and stay safe. Stay safe.
Yeah, yeah.
Bye. Thank
Bye-bye.
you. Thank you. Bye. Stay home.
Bye.
Stay safe. Okay.
Yeah, it's right.
This is the rule.
Yeah, yeah.
Ciao. Ciao.
Bye-bye.
Bye-bye. Thank you much
Thanks. Bye.
for the comments. Bye.
Thank you very much. Bye.